Good morning or good evening to everybody listening to our presentation today. I'm Toni, and together with Andrew, we are going to show you new entity query functionality. So we have prepared a website on which you can read in detail through some examples, and we are going to present them to you, or part of that. But first, I'm going to give a quick introduction to the idea of entities. And then Andrew is going to continue with some more detailed examples. So a quick introduction. So Andrew and me. I'm Toni, and I'm the entity framework developer, amongst other things. And Andrew is developing entity content. And he's, for instance, known for his work on the food ontology. Yeah. So let's start with entities. What is an entity? So the typical way to discover an entity is to use the natural language interface, like you see here, and type in something that you want to know about. And I did that for you, zebra. And then when you hit enter, you get a possible interpretation. And in this case, you got a yellow box, which means, yes, you got an entity. You get also a menu that shows you that you could have chosen a different interpretation because I didn't give so much context, so I could have thought about something else, and here I can choose what I actually wanted. But I'm fine with that interpretation, so I click the checkbox. I can do that, or I don't have to. And then I'm done. So this is an entity. And if you hover over it, you can see, for instance, its type and its so-called canonical name. And now, if I evaluate it, you might be wondering, oh, why did that not work? But it worked well. It did exactly what it was supposed to do, namely nothing. The entities are meant to represent things, which is a really important concept. If you, for instance, thinking about analyzing a text and extracting or annotating what kind of things are mentioned in that text, you need something that represents the things that you're finding in the text. And entities, or in general identifiers, are the fundamental thing to do that. Now that we have an entity, we can ask for properties of those entities. Yeah? In this case, I have a zebra, and I want to know the maximum speed and the image. And when I evaluate it, I see the speed and the image. Yeah? So that was a crash course on entities. Represent things and ask for properties. Now, the first new thing is computed properties. You can specify an arbitrary expression using an entity function and use that like you would use any other property. For instance, here I again take my zebra and I ask for the maximum speed, the image, and the color negated image of the zebra. And when I evaluate it, I see that the zebra, after negating its color, still is a zebra. So you could have done that manually, but it's a really convenient function that we'll see in use later. So the next concept is entity classes. And what is an entity class? An entity class is a collection of entities. Here we are talking about the class of all planets. If you evaluate it, you already might wonder, why did it not work? But again, it worked exactly as it should be. It did nothing. It just formatted nicely. So this object, which has this little symbol on the left, indicates a class of entities. In this case, the class of all planets. To get its members, I apply, for instance, entity list to it. And you see, for instance, a famous planet Earth or Mars. And you might be wondering, in which order are those planets? Are they in order distance from Sun or something else? Well, the documentation says nothing, which means the order of entity classes is not defined. That means it could be anything. So that's where our new functions come in handy. I can define now with a sorted entity class a class of entities that is sorted by a certain criterion. In this case, I define a sorted class of planets which are sorted by the distance from Sun. And now I can be sure that I get those planets in the order that I expect. However, I can not only sort by a property, but also by a computed property, by an arbitrary expression. In this case, I'm sorting by the distance from Sun divided by the mass. And you see the order is different. Oh, by the way, here we've seen how we can extract properties for an entity. We can do the same for classes. If I say, for instance, let's try that. A class of entities can extract a property. It is interpreted as taking the property for each entity in this class. Yeah? Next, instead of just ordering, we can also filter classes. What does that mean? We start with a base type or a class, and then we apply a condition that limits the entities that are in that class. For instance, here I start with all polyhedra, and then I select only the ones whose phase count is larger than a given number. Let's give that class a name. And then I can retrieve for all the entities in that class, say the image. Yeah. So all of those seem to be having more than 150 faces. The next complicated and the second most complicated new feature is the aggregated entity class. So let's start slowly of what we're doing here. So here we are starting with planetary moons. It's the first argument of the aggregated entity class, but we could use any other class. Oh, by the way, the great thing is that you can nest all of those new entity class constructs. So we're starting with all planetary moons. Then we group them by orbit center. And for each of those groups, we give the count of the moons and the total mass of the moons. Yeah. It's again an entity class, and I store it in this variable. Yeah. And let's look at the entities in that class. Yeah. Those are new kind of entities. They have new formatting. They have this nice little symbol at the left that indicates aggregation. And they are formatting, mentioning its value for the group condition. Yeah? So for instance, this entity represents the group of planetary moons orbiting Earth. Same for Mars and whatever those things are. Yeah? This class has just three properties, namely the orbit center, the total mass. Those are the aggregate properties that are introduced here. Well, and the orbit center, which is the group condition. And then I can look for the values. Yeah, for instance, of the group of moons circling Mars, and I see, well, there are two, at least we know about two, and that's their total mass. Now I think comes the most complicated of the new query constructs. And for that, I need to explain first something. And the best thing to explain things is using Pokemon. So we have this Pokemon, I don't know how to pronounce it, maybe Tentacool. And let's get the image and the type of this Pokemon. Yeah? We see the type is a list, and that's an important thing that we'll use later. Yeah? So each Pokemon can be of various types, maybe one or two or maybe more. And each Pokemon also has a value for its attack property. What we now want to do is, for a given type of property, we want to determine the mean attack. Yeah? And there are many ways to do it, but for this example, we are going to do it with a new function called combined entity class. Yeah. And the combined entity class is useful for combining classes of entities in the sense of the SQL join. Yeah, we are starting with all the Pokemon types, forming all combinations that satisfy this predicate. Yeah. And to get an idea of what this looks like, so we're going to make an entity list and taking the first element from that class. And here you can see the type is a little bit more complicated. It is the same as for the aggregated entities, which show a complicated type. And it has one Pokemon name and one type name. Yeah? And those new entities have a collection of properties. And those properties are the properties from type 1 plus the properties from type 2. You can convince yourself by counting the properties by the type. Yeah? So we have so this new entity has 29 properties from Pokemon and two properties from type. Yeah. Now we use a function that we used before, namely the aggregated entity class. Yeah. We start with the combined class. We take the mean of the attack. Yeah. And well, let's look at the values. Yeah. Those are fractions. Let's look at the numeric value. So now you have basically for each type of Pokemon, its attack, its mean attack. And I think those are most of the new query primitives. And now the question is what you can do with it. Originally, those new query primitives were introduced to allow querying relational databases. And there's a dedicated talk for that. So I'm going to just mention it here. But the idea is that you learn one query language, namely the entity query language, which means you filter, sort, aggregate, and combine classes. And with that, you can query different data sources, namely the built-in entities, from which we have a few hundred types. You can query your own entities. You do that by registering in an entity store. Or you can query relational databases by constructing a store based on a relational database. Yeah. That's it. One more thing. Maybe some of you have heard of Sparkle, and there will be a dedicated talk about that. But I just wanted to mention that the same example here could well be done using very experimental technology. So we are adding support. We have support for Sparkle now. And using that, the whole queries are going to be easier to read. Yeah? Or yeah. You can view every entity type or collection of entity type as a graph, and then you can specify a graph query and a corresponding aggregate and apply to an entity type to get a result of the same type. So that was my short introduction. So maybe I now give to Andrew to show you some more examples. Yeah.
Yeah, sounds good. Okay, let's see if I can share my screen real quick. Okay, I think everybody can see my screen probably, right? Okay. Yeah, so Toni had shown a little bit of the entity query functionality page here that we have for version 12 with the language here. I'm going to go through some of the examples on here. I probably won't go through some of the early ones because Toni went through some of the basic stuff in this row. The next two rows cover a lot of built-in entity types that we have in the language. I'll cover a couple of those as well. And they kind of highlight all these new entity class functionality as well. This second to last row here is a little more advanced. Most of these involve entity stores for various things. And then I think the last row here is also much more complicated and more advanced uses of entity stores as well. So I guess as a start, maybe we should take a look at this one here. So this one is a neat one where we can look at continental plates and how they change and move over time. So for example, if you look at geological periods, you can write a simple filtered entity class to take the entity class of periods. And then you can use a simple entity function here to take those that only whose time range is within the last 550 million years. And so with just a little bit of code there, we're able to get that kind of stuff. And then we can use another entity function, which I've just called plate outline here, which more or less grabs all of the continental plates for the entity. And then down here, we grab the keys, we sort them, and then we map this column function over all of them so that we produce a column where the top row is just a common name for it. There's a date that goes below it, and then we produce a little simple geographics that will produce stuff that looks kind of like this. And we do that for all of the entities, the ones that match the filter that we had there, and just by doing entity value of the class and then this entity function for the property, so to speak, we can just wrap it in list animate, and very easily we can see how the geographic plates moved over time from there. So this is just kind of an example of a neat little thing you can do with some of this stuff. So I'll let it play a few times here so you can kind of see how things go that way. But I highly encourage everyone to try it out and see how it goes that way. Let's see here. Moving forward a little further, we can take a look at this one, which will show off a little more stuff. Again, I think this is mostly for aggregated entity class, and I think there's some filtering too. So we have a lot of information on hundreds of thousands of famous people with actors, athletes, politicians, and that sort of thing. And so I thought it would be interesting to take a look at an entire generation of people in our data. And so with this, it was pretty easy to write a simple implicit entity, which has been around for a while, where I've just grabbed all the people whose date of birth is between 1946 and 1964, which I think most people agree is the range of what the group of people or the generation is called baby boomers, for example. So with that, you can just limit people's birthdays between those two, and we can grab only those whose nationality is the United States, for example. So this would be American baby boomers, basically, which is what I've named it there. And with that, you can do a quick query and actually pull out, about 23,000 or so people that way. But since we're going to be looking at birthdays, we should probably make sure that the birthdays are actually down to the granularity of a single day. And so this is where filtered entity class comes in really handy to be able to write a simple little function that says, hey, grab the birthday, and then grab its granularity and check that it matches day. That's a property of date objects. So like if I do now, for example, this gives me a date object, and I can take this date object and I can say, grab me the granularity. So this is an instance, for example, but if I did today, for example, that's a different thing. And so then here you can pull out the granularity from there, and you can see that it's down to a day. And of course, you can do that for minutes and hours and so on. But we're really only interested in things that are days rather than, for example, a year where it may not be known exactly when they were born, or a month or something like that. So when doing that, that trims out a couple hundred more, maybe 100, 200, something like that. And then from there, it's not too hard to build an aggregated entity class from that filtered one, where we can aggregate things according to which month they were born in. So if we look at this line, this is the birth month count property that we're introducing, and it is computed by taking all of the entities in the class and then just getting the length of it. Then the groups are created by taking the birth date of a single entity and then figuring out what month they were born in. And I use that using date value. And with that, with a little bit of work, you can see that, 1 goes to January, 2 goes to February, so on and so forth, and that gives us some nice information there. And then you can drop that into a bar chart, and you can see kind of how things go. Noting in our set, at least, of the famous people we have in our database, at least, it looks like most baby boomers were born in October, comparatively speaking, to the other ones. So to take it a little further and to do something a little bit more interesting, we can also use moon phase to be able to group the birthdays and that sort of thing. So this is kind of a neat little thing to do. So the first thing I do here is take all of the birthdays, I delete all of the ones that might be missing, and then union those so we get rid of the duplicates, and then feed that to moon phase and ask for the entities that come out so that I know for any given date, I know what the moon phase is. From there, I can write another aggregated entity class where the groups are constructed by taking the birthdays and feeding them to this birth date to moon phase lookup table as an association. And then those groups, I can pull out the occupation property, which already exists in our data. And then I can take the results, which are already in lists. I can flatten them all, get rid of any missing values, and then count them all up. From there, it's not too hard to be able to do a little bit of processing on that, and then we can have what moon phase has which counts of which occupations, and what better way to look at those than a word cloud. And so here you can kind of see, for example, if we look at only full moon and new moon, for example, the results are a little bit different for each. It's a lot of noise in there, but at least you can kind of see some interesting stuff that way, and is a good exercise in learning the new individual functionalities and that sort of thing. Yeah. So going a little further, we can take a little bit more, going a little bit further, we can talk about food, which is my area of expertise in Wolfram language stuff. That's mostly what I work on, a lot of food stuff that way. This is a really good example here, which rather than just do it right here, I think I can do it live in the notebook here. If you give me 1 minute. I should be able to do this without too much trouble. For example, here, it might be a little easier if we do it this way, and I'll blow it up so it's a little larger here. I think everybody can see that. Basically, if we take this implicit entity for refried beans, for example, we can take that class, that entity class, it's implicitly defined based on foods that have beans only and their preparation is refried, and then we can use extended entity class to be able to take the class that was already there and add a property called protein to fat ratio that just uses an entity function to be able to take the relative protein content and divide it by the total fat content. And I've put a quiet in there because sometimes the total fat content is 0, and if you divide by 0, it will issue a message. So from there, we can also use filtered entity class on the class again to only take those whose protein to fat ratio, which is now a property of that class, that look like numbers. That way we don't have indeterminate and other things in there that can mess with the values, especially when looking for, comparing largest and smallest values, for example. So in order to do that, if you're looking for which ones have the most and the least, for example, you can use sorted entity class to do that. And so in this case, you can say, take the class that I had before, and then look at the protein to fat ratio property that we introduced before, and sort them so that they are descending, and only take the top 10. And so when we do that, we produce our class there without too much trouble. Now, if you evaluate all this stuff right now, you'll see that it all evaluates almost instantaneously. That's because the class itself is a representation of a query, more or less, and so it hasn't actually done the query. So at this point, we would use entity value, or the shorthand notation here, to ask for the property and get the results in the form of an association. And so with that, you can see the results are here. And now you can see that, this one has the highest protein to fat ratio. So it's almost 12, at least a couple of these are almost 12. And the later end all the way out to 10 are closer to around 7 or something like that. Okay, so that's more or less the food example there. Let's move on a little further. Moving past the food ones, we can also take a look at the hyperbolic mathematical functions that we have. So I can do a little bit of that in greater detail here, if you give me one moment. So we have a lot of information on mathematical functions. And let's see here. Sorry, I'm having a little bit of trouble looking at this. Here we go. So in the Wolfram language, we have a lot of information. So for example, here we have entities on mathematical functions. Here's just arc cosine or the inverse cosine function. And we have a lot of detailed information. So if I just grab these here, one of the properties is the alternative representations, for which there's a lot. There's like 2,000, over 2,000 representations for arc cosine. And so just grabbing a random sample of them, you can kind of see a handful of them here. In particular, we have an entity class for the hyperbolic functions. So here I've just named them built-in hyperbolics. And I can list out what they are, and of course there's 6 of them here, but this is an example of an explicit class, whereas in the food one, which I'll look at here, this is an entity class where we've put in a list of rules that say, here's the property and here's what constraint should be done to match that. Whereas this entity class here is an explicit one, which you can kind of see if I do, say, input form on this. You can see that it's written out as the type, and then there's a string in the second argument rather than a list of rules there, which is what the implicit ones are for. Let's see here. So yeah, going forward, we can list out which entities are in there. We can kind of see those. And let's see if I can scoot a little bit further here. One thing we can do is use entity function to be able to write out new properties. So here, for example, is just a simple hypergeometric representation property, where basically what we do is we take the hypergeometric representations property here from a given entity, and then we only select those out that don't involve a specific pattern, particularly involving hypergeometric PFQ, and so it's kind of complicated, so we leave those out. And then we take the first one according to leaf count, which is just the number of leaves in the actual expression. So that should give us a nice, simple hypergeometric representation of some of these functions. We can also do a similar thing with a different one for making simple plots, for example, where we can just plot them out using the new reim plot and kind of look at things that way. And we can even do another similar thing with differential equations to pull out a simple one where we just grab all of the differential equations for the entity and get rid of any stuff with hold pattern and conditional expression and so on. And we just take the first one that doesn't have any trig functions in it. So once we have all these defined, then we can use extended entity class to be able to add those properties. So for example, here, this is the simple hypergeometric representation property. So that's like the standard name or canonical name of the property. And on the right-hand side is the implementation or the entity function. That's this thing up here. And the same is true for, simple plots and simple differential equation from there. And so now we've extended it right here. So for example, we can get the plots going if we want by just calling simple plots on that one. And then we can drop them into a simple graphics grid here, and we can see them all in one shot. This will take just a second. And so you can kind of see them all right here without too much trouble that way, and kind of make a nice little plot for each one. And if we look at the hypergeometric stuff, here's a little helper function that I've defined just to clean things up a little bit and make it look nicer. If we use that helper function and map it over the extended hyperbolics call for all of the simple hypergeometric representation on all of them. We can drop it into a column and do a little bit of formatting, and now you can kind of see the hypergeometric representations of them. And in a similar fashion, we can do pull out the simple differential equations for each of them without too much trouble that way. And so that kind of gives a little bit of an overview how you can extend even explicit entity classes with your own entity function properties and that sort of thing. Let's see, I think we've got a couple questions here. I might take a look at those real quick here. Yeah, I think Toni, you pointed out that the database people will be able to talk about the relational database stuff, I think there.
Yes,
so.
Yes, exactly.
Okay, and see, there's another one here. So it would also be really nice to be able to write my own SQL queries for entity function. Ooh, yeah, I can't really speak to that one, Toni. That might be more.
We leave those details to the database people. Yeah.
Yeah. Mm-hmm. Okay, so let's see here if I can pull up this again here. I should be able to go over this way. All right, so we can keep going here. All right, so we can look at a few other things. There's a neat one here with some entity stores. So most of these have all been built-in entities at this point, but now we can talk about a little more entity stores and that sort of thing. So in particular, there's this neat one here that I've worked with one of my colleagues with. He's a chef. He has a lot of background with culinary science stuff. And so one of the things he was interested in was in award-winning restaurants. And so he wanted to be able to gather some information about those things. And so this is a neat little project that he did, and we've cleaned it up and showed you kind of how to do it here. It's kind of a neat little data science-y kind of project that uses a lot of this technology that we've introduced in version 12. So to start with, what's really handy is to be able to use data bins to be able to keep track of data without too much trouble. So with a simple little call here, you can just create a data bin with a given name, and you can build a simple cloud form without too much trouble. And here, this is a screenshot of it, for example, where you can fill out the name, the group, phone number, cookbooks, various sorts of information that was he was interested in. And so once he went through and cleaned all that stuff up, we needed some way to be able to sift through it. And so basically, you can take all the contents of the bin, you can download them, and then, for example, we can look at just one entry where, he's got the name, phone numbers and things like that, websites and the whole bit, including cuisines and stuff like that, as well as, when the date, when the restaurant opened and that sort of stuff. So with a little bit of code here, which I've kind of hidden away in a cloud object here just to keep things a little simpler, you can actually process the data, and you can take a look at it and make it into a format that Entity Store will be able to handle and know what to do with. So for example, here, this is just some of the information that's available. So like for one thing, we have the restaurant group, for example, as award-winning restaurants. That's sort of our base type, if you want to think of it that way. And then there are awards that we have, like 1 Michelin star and other various things there. So from there, it's not too hard to actually create the entity store. And then once you've got it, you can just register it from there. Once you've got it registered, then it all handles, as Toni pointed out, basically it uses all of the same query language stuff as before that we've seen for the built-in stuff. So for example, you can just grab out properties and ask it to be in the form of a data set. And so you can see here, it's just a little data set that kind of shows some of that stuff off. And we can do some more interesting things like, look at the opening date, for example, feed it into date histogram, and you can see that most of them are pretty new, but there are a couple quite old ones, which we'll get into it a little bit here. There's also a lot of information on what awards they have. And so basically using sampled entity class, we can take the entity class, the implicit entity class of all award-winning restaurants whose awards include a single Michelin star. And we can use sampled entity class's second argument to be able to say we only want 15 because there's quite a few of them. And so we limited ourselves to only just 15 of them. that way. And then again, you can use a sort identity class to sort them by opening date, for example. So this is the same implicit entity class here, but now we're sorting them according to the opening date, and we're grabbing just 5 of them. And we want to get back the opening date and the cuisines properties and put it in the form of a data set. And so you can see some of them are even in the 1800s. There's one in the 1800s, and some of them are pretty old, and their cuisines are kind of varied. So kind of interesting that way. With a little more effort, we also have the locations of all of them. And so with a little more effort, we can actually see where they all are. I think some are even in Hawaii. Most of them are in California, it seems, and quite a few in New York as well. So that's kind of interesting there. However, we can go a little further with the location. Like, for example, if we only want to look at one Michelin star restaurants in New York City that are currently open, we can do that without too much trouble. This is a similar thing here, where we just look up all of the entity classes, and we limit ourselves to one Michelin star, and that they're currently operating. And then we can use filtered entity class to be able to take those that are within New York City. And otherwise, we just return false, so it doesn't. So we only take the ones that are actually in the city itself, according to our stuff there. And then from there, with a little bit of work, we can actually visualize where all of those restaurants are. And at that point, it's pretty easy to use travel directions to be able to find the shortest tour to run through all of them. So for example, here, I've done it both for driving and walking, so it kind of makes a neat way to see the differences in how you would get around to visit all of them. It's only about 40 miles or so. It'd take you a long time to do it, I'm sure, but you can kind of see things that way. So this is sort of an optimal tour to visit as many of these award-winning restaurants in New York City if you're interested. And there's some neat, interesting differences too in the paths, like the walking and driving. You have to drive around certain things and stuff that way. But yeah, so that's kind of a neat little example that way. I guess I will move on to the next one. So another one that we worked on was with organizing family recipes, for example. And so this one, we've made a little entity store out of some family recipes, and then found ways to get them into the Wolfram language and represent it and do some interesting things with them. And so we've made use of a few interesting things. Like, for example, this one here that would be on a card, for example, that was handwritten. It's kind of hard to read handwriting type stuff. So instead, it's a lot easier to just speak the recipe. And so what we did is we used audio capture and speech recognize to be able to just read off the recipe, and then from there it produces some text. And it doesn't get everything quite perfect, but you can do a little bit of processing on it and clean some things up, and ultimately, without too much effort, you can make a nice little symbolic representation of the recipe, where we've got the raw text itself for a given step, some cooking actions and ingredients, all in terms of our existing built-in entities and stuff that way, including quantities for cooking times and that sort of thing. And so once we've got that, we can do some more interesting things. And so basically the recipe becomes an entity. So going forward, another one that another kind that was in some of the recipes we were looking at were typewritten recipes. So like someone had a typewriter and they just wrote it out. And so scanning those in or just taking a picture is sufficient to be able to get pretty far just by using text recognize. At least that would get you kind of close to be able to process things without too much trouble. So in this case, we just did that, and the results are actually pretty well, are worked out pretty well. And so from there, again, it's not too hard to take that information and transcribe it into a symbolic form that is ready to be used in Entity Store, for example. So we've got all the little steps. We have temperatures in there and those kinds of things with actual quantities, and they are aligned to again to the to our built-in entities and so on. And with a little bit of effort, it's not too hard to do this same sort of thing with various different ones. Another feature of entity stores is the ability to put in your own classes. So like we've broken them into breakfast dishes and dinner entrees and cakes and so on. And then we can also do some other stuff with other properties that we'll kind of get into as we go along, like the ingredients and stuff from there. So we can register that entity store so it's available for use. And then it's not too hard to set up other properties. So for example, here we can pull out just the ingredients, which get returned as an entity group from the information that's there. We can also add a qualifier to it, for example, to be able to scale things up and down by a certain factor. So here, you can see this was 1 pound and 1 clove, but here if we put a factor of 2 in there as a property qualifier, all of these things get multiplied by 2 as needed. And again, you can implement more properties and that sort of thing to be able to look up nutrition and those kinds of things there without too much trouble. And another neat thing is that if you work on this sort of stuff, you can actually create strings out of this stuff that you can feed into word cloud. And so with the simple property addition here, you can make a nice little word cloud that sort of organizes the ingredients based on their fraction of the recipe, basically. In this case, it is scaled according to the calorie content and that sort of thing. So you can scale it to various things, and it's customizable that way. And another nice thing about being aligned to all of the built-in entities is that you can reuse existing properties and stuff to be able to generate other properties. So in this case, you can take all of those individual ingredients, put them all together into one entity group, and then call a nutrition label on it. And that's how we can make a nice little nutrition label out of an entity that we created for the entity store, for example. And it's not too hard to do some other stuff. We looked into various other things. We made some neat graphs and stuff like that. But in order to keep the example shorter, we kind of stopped here where we made a simple little thing where you can actually click on this. This is actually a flip view. If you look into how it's set up, and you can just click through the ingredients, or rather the steps, and they all give you the actions that you need to do, the text that's there, how many steps are left, the equipment that's there, and some ingredient stuff that way to be able to, for example, if you set this up on a computer in your kitchen, for example, you'd be able to just go over and tap one button and be able to move through to the next step and go back and forth and that sort of thing. So yeah. Let's see here. So yeah, so that's more or less on that side of things. There's some other more advanced ones here that I'll kind of go through a little bit. Toni had mentioned some stuff about Sparkle, so I'll talk about this one a little bit. If anyone has seen my blog post that I did a couple months ago, I think it was, on analyzing Math Overflow, I built a utility that converts archive dumps of Stack Exchange websites and converts them into entity stores. And so with that, you can do some really interesting things. There's a whole blog post about it. Feel free to take a look at that if you're interested. But one of the things that we were able to do too is to do it for other things as well. So for example, we did it for the pets.stackexchange website as well. And so for example here, if you build a little entity store here for basic pets, so I've built a simple one here with cats, dogs, and so on, and I added some basic properties to them that come from mostly aligning to species data and stuff like that that's already built into things that way. With a little bit of cleanup there, you can make a neat little entity store to do things. You'll have to register it, and then you can do entity list on that, and you can get results that way, for example. Another neat thing here is that you can see what the properties are. So just based on the alignment, I can pull out some strings where we can get names for various things that way through the alignment to species data. And from there, if we register the Stack Exchange entity store that I created with my utility, you can just download that from the cloud and register that. We can use both of these together to do some interesting things. So for example, with a little bit of work, you can write some code here to be able to extract out pet names. So just given these sorts of strings, you can go through all of the posts in that Stack Exchange website and pull out all of the entities that go there. So for like this particular one, they mentioned cat. They mentioned cats in there, and so then it gets pulled out that way. And you can get all of them just in one simple entity value call, which I've stored here. And then you can add a new property that, let's see here, yeah. So then from there, you can take that information and group things according to what pets are in there and that sort of thing. And then you can take a look at how often each one is found. So like you can see that, mostly on the website, it looks like people talk about cats and dogs way more than they talk about fish, rabbits, birds, and so on, which is perhaps not surprising. Those, when people think of pets, they mostly think of cats and dogs, I guess. And then from there, with a little bit of Sparkle, you can write a little query or two to be able to get all of this information here without too much trouble. So by looking at only a certain set of interesting tags that I've iconized away, when I'm looking for cats and dogs, I can use Sparkle stuff to be able to figure out, by going through the posts and then pulling out their pet types, then I can take those and aggregate them using some Sparkle aggregation stuff here, and then do a little bit of work at the end here to get it into a form where we can get it into what bar chart is happy with. And then once we have it in that form, we can make a nice little thing here where we can see the fraction of posts in a given tag. So these are the tags where dogs or cats are mentioned more than the other. So you can see that dogs are more common in training, for example, than cats. I guess people don't train cats very often, it seems. Or people talk about containment and that sort of thing, whereas cats are more common in feeding and psychology and eating and behavior and those sorts of things for those post tags on the Stack Exchange website. And there's also some other stuff too. For example, like with a little bit more effort, you can do some neat stuff to be able to find out which pet types are frequently mentioned together, where you can see the most common ones are cats and dogs, birds and cats and mice, and that sort of thing. And you can make a neat little network and do a little bit of analysis that way. So yeah. Yeah, and so let's see, we could take a look at a little bit more here. We've got a little bit of time, I think.
There's one question that I want to comment.
Sure.
So someone is asking about an entity store built from an RDF store. Yeah. That is analogous to an entity store built from a relational database. So it's a natural and very good feature request, but it's really hard to do. And we've been considering that for quite some while. The issue is that RDF is a very simple and general data model. And it is pretty straightforward to express entities in terms of RDF. Yeah, you just build up the triples. But the reverse is not so easy, because it gives you nearly no limitation of how you have to structure your data. So then it is really hard to find how to, in general, represent RDF data in terms of entities. So we've been considering it, but we haven't done it yet. So to answer that question. Now maybe back to Andrew.
Oh yeah, absolutely. Yeah. Yeah, I don't see any other questions here so far. So yeah, I guess we'll just keep going through examples. So let's see here. So this was a neat one that I did on extracting flight sequences from text. So for example, we have in our built-in entities, we have a lot of airports. I forget exactly how many, but it's pretty substantial. It takes quite a while to run some of the code in here, because it's quite a lot of data to go through. So for example, here, what I do is I just gather out all of the airport codes that we have. So these are 3 or 4 digit letters. And so with a little bit of code here, I can actually turn it into, given a code, spit out the entity for for an airport entity. And with that, we have a lot of other information, including runways, location, those kinds of things from there. And then again, using that tool that I had mentioned before, by analyzing the travel.stackexchange website, If you import that entity store and register it, we can do some neat stuff from there. So with a little bit of code to be able to extract out airport sequences, you can actually take for a given entity, you can actually pull out what pairings or connections of airports there are based on the codes that people have written in. And so it's really not too hard to go through and look for all of the stuff there. So I've kind of got some code here. It's a little messy, but you can kind of see that I've basically connected them if there was a word like from or arrows or to between all of them, and then I do a little bit of cleanup on the data and stuff like that. But it's not too complicated there. And then if you do that on all of them, and then you delete all the missing values, you do some cleanup on flattening, counting them all up, and then sorting them, then you can see what the most common airport sequences are. So we can see that it looks like stuff from London to Amsterdam, for example, shows up quite a lot in those. So you can kind of see these are, with the nice thing about having it aligned to the built-in entities is that you can see where they have where they are on the map and connect them by drawing a line through them just with some geolist plot type stuff. And then if we go through all of them and we kind of scale them so that they all show up kind of nicely, you can see these are the most common, these are the flights for all of them mentioned on the site, all the flight sequences drawn together with a little bit of opacity on them, so you can kind of see them with a nice background, and that kind of makes for a neat little image to work with from there. Going a little further, we can use sorted entity class here to be able to find the posts that have the longest flight sequences. So for example, these here, by just using sorted entity class, we can introduce a new extended property called longest flight sequence distance, where we can extract out all of the mentioned airport sequences, and we want to find them, and then when we're done, we just get the max of the distance of all of them by using geodistance. And then we find those, and then we do longest flight sequence distance and sort it according to with sorted entity class, and sort them by that property in a descending order and just grab the top three. So you can kind of see those entities show up there, and here's the information that goes with them, and so you can kind of see the posts and links to them and that sort of stuff in the results. From there, you can see what the actual sequences look like on the map, and you may go, well, you know, these don't look too bad. I mean, they go pretty far, but part of the reason why there are more things here is that it's they're actually round trips, some of them. So the longest one is this one here, which goes all the way down and all the way back. So it's quite a bit longer than most of the others because it is a round trip in that way. So, but anyways, that's some neat stuff that can be shown there as well. So, so I think at this point, I guess I can maybe show one more example, or are there more questions, or because I don't want to take too much time here. I think we have to be done in a little bit here, right? Toni, do you have any other things that you'd like to point out at this point, or?
Nothing more. There are no more questions, and
okay. Yeah, then yeah, if there's no questions, then I guess we'll go a little further and we'll take a look at another example or two here. This one's a neat one where you can take another Stack Exchange entity store, for example, and you can analyze kind of the dynamics that go in with it. So we get to use a lot of time series functionality to be able to do stuff, which we've had for, I think, a couple of versions, if I'm not mistaken. So for example, if we take one of the vegetarianism Stack Exchange, which is a reasonably small Stack Exchange to make the processing of this not take forever, you can download the cloud object because I've just stored it there as an MX file, and then you can register it. And then if we look at, for a specific user, we look at their approximate reputation time series. You can get the reputation that they've done stuff that way, so that we can see how things go. So you can kind of see that, very early on, this user got a lot of reputation by answering questions and doing various things that way. And then there are large stretches of time where they didn't really accumulate too much, and then a little bit at the end there. But it's mostly flat after a while. And so we can kind of see the we can use a sorted entity class to find those users that have the highest reputation and get their full time series with those. So with just a little bit of effort here, we can get the 5 most common ones and see that, these are the users with the most reputation. And if we plot those all out, you can kind of see here that, the one with the highest one is almost 7,000 reputation points. And it looks like most of them, except for this last person, started very early on, comparatively speaking, that way. So let's see here. So we can go a little further with that, and if we get the reputation histories for all of the users instead of just those top 5, we can aggregate all of them just by doing a little bit of work here to put them together, and then we can use aggregated entity class to be able to take all of them and sum them all up. And so this will give us the total reputation time series for the entire site since it was created. And so you can see it's sort of follows a similar pattern, although it's more linear in growth after the initial phase of growing pretty much. So there was probably a lot of users that were added, and then it kind of slowed down over time and more or less became constant growth, it looks like. And so in order to compare with that, we can see the number of users over time as well, just by looking at the user creation dates. So you can do that in a similar fashion here, again using aggregated entity class to be able to pull that out and aggregate them properly that way. So you can see there were a lot of users added, and then it kind of stopped for a little bit, slowed down a bit, and then it became more or less linear for a long time, which is kind of interesting that way. Then from there, without too much trouble, if we resample the time series so that they can be divided, we can get the ratio between them and actually compute the user count to ratio or rather the reputation score to user count ratio there. And so you can see that it really spikes up very early on, probably because the number of users that were using it were not it wasn't really well known perhaps, and so not many users had been on. And then after that it switched right back down to being very low, and then it spiked back a little bit, and so it's kind of this oscillation kind of thing going on for a little bit, and then it kind of leveled out on very slow decrease over time, which is kind of an interesting thing to see for the site. It'd be interesting to see that for other sites as well. I haven't done the analysis on that, but it could be done. Going a little further, we can make use of filtered entity class to be able to grab all of the users whose reputation history has at least 25 data points. That boils us down to about 46. And then we can look at the number of days since their account was created to see if we can fit them to a power formula of some number beta times t to the alpha, where we want to find what beta and alpha are to try and see what kind of growth rate these things are, would be kind of cool. So I use find fit to be able to do that without too much trouble. And you can, use that to be able to see some other information about it, including, the min, the max, median, standard deviation, and those sorts of things. So then, for example, we can take a look at the alpha, for example, what the distribution actually looks like. So here's a little histogram that you see. Most of these are on the low end here, and then there's 1 or 2 that are kind of outliers way at 1.0 or so. It looks like, I think that's the maximum value anyways. And so if we look at just the outliers, we can see what the parameter values are for those, and we can also visualize them. And we can see that these are usually users who didn't gain substantial reputation until a long time after they initially created their account. So like this one looks like they made their account a long time ago, and they didn't really gain any reputation until almost a year later. It looks like, maybe not quite a year, but a good fraction of a year later. And then 450 days or so later, they finally really started to pick up on gaining reputation on the site. And most of these other ones are much closer to the curve that we estimated them to be, and so they work pretty well on the other end. So that's kind of neat that way. But So I guess it's some. So yeah, there's a lot of neat stuff here. Definitely feel free to go through all these sorts of things, but I think I may stop here since it is about 2 o'clock on my time at least. And I guess we can take a look at. I have a question over here. Let's see. Always wanted classified text tags for Mathematica Stack Exchange questions. Oh yeah, that would be really interesting. And in principle, using this utility, you could probably do that. I haven't really had a chance to look at the Mathematica Stack Exchange, but that is definitely a very interesting one that I'd like to do that. Definitely a lot of machine learning type stuff, including being able to get the tags out for them. That would be a pretty neat thing to do. So, yeah.
Well, thanks, Andrew.
Yeah.
I think we are done with our presentation for today, but we are having probably 2 more presentations coming up that go, or that would be a natural candidate to watch after this one. Namely, one is the database presentation that shows the entity query functionality, how to use it for relational databases. And there you can ask more detailed questions, about what's working and what's coming up. And then another talk about RDF and Sparkle that I'm going to give. Yeah. And I think with that, we are finishing for today. And thanks, and see you later.